Multiplying and dividing rational expressions. The first thing I want you to look at and want you to understand is what allows you to cancel. If you take a question like 3 times 8 divided by 3, notice how that's 24 divided by 3, which is 8. And if you look back at the original question, you see that there was a 3 above and a 3 below. And 3 divided by 3 is 1, and 1 times 8 was 8. I can see the answer right here. The reason that worked is because you were multiplying. You need multiplication between your pieces, between your factors, in order to cancel. If you take a question like 3x plus 6 divided by 12, notice that you can't cancel the 3 and the 12. Students want to do that all the time. And the reason you can't do that is this is 3x divided by 12 plus 6 divided by 12. Both the 6 and the 3x are divided by 12. Now, I believe I've shown you before that there is one way you can simplify this by finding a common factor. You could divide everything by 3. You could divide 3x by 3 and make that x. You could divide 6 divided by 3 and get 2. 12 divided by 3 would be 4. And I can see the answer then is x plus 2 over 4, which would be preferred to simplifying this. If you simplify this, you could divide by 3 and get 1x, 1 and 4. Divide both by 6 and get 1 and 2. And you could say that this is x over 4 plus 1/2. But notice that there's no common denominator. It's nicer to have it as one piece and say the answer is x plus 2 over 4. Now, dividing everything by 3 is one way to do that. But in general, what you need to cancel is multiplication. What you want to do in any question is create multiplication so that you can cancel. And the way you do that is by factoring. Factor and then cancel. Factoring creates that multiplication. Notice in the numerator how 3x and 6 have a greatest common factor of 3. You can say that that's 3 times x plus 2, because if you take a 3 out of both, you get x plus 2 here. 3 times x is 3x. 3 times 2 is 6. Now, that's over 12. What you've just done is create the multiplication you need to cancel. It's right there. I can divide by 3 and I get 1, divide by 3 and I get 4, and I get x plus 2 over 4. Now, dividing this all by 3 works great, and that is one way to do it. But in general, as the problems get more complex, you want to factor and cancel and do what we did right here. When I give students a question like this, what they tend to want to do is cancel right off. And they think that they can cancel the x squareds and cancel an x and a 6x and maybe make that 5x. Or 8 and a 20, divide them by 4, and I get 2 and 5. But the problem is that doesn't work because of the addition between the x squared and the 6x and the 8, and the subtraction between the x squared, the x, and the 20 below. You cannot cancel that way. You need multiplication between your pieces, there will be factors to cancel. And as I said, you factor in order to get that multiplication. Above, we have a standard form. We're looking for factors of 8 that add to 6. There's no number in front, so the 8 is what makes that 6. That would be x times x, get x squared. This number times this number makes positive 8. And so it's either 2 positives or 2 negatives. This is a plus. It's going to be 2 positives. Factors of 8 that add to 6 are 2 and 4. Below, x times x makes x squared. This number times this number makes negative 20. How do you make a negative when you multiply? It's got to be a positive times a negative. I need factors of 20. One will be positive, one will be negative. When I add them, they end up subtracting to 1. They will add to negative 1 or they subtract to 1. That would be 4 and 5. But again, when I place them, they have to add to negative 1. So that's negative 5 and positive 4. Now that I have that multiplication, I can cancel. Anything divided by itself is 1. X plus 4 divided by x plus 4 is 1. Those drop out because 1 times anything is itself. 1 times 10 is 10. It has no effect. Up above, I'm left with x plus 2. And the only thing that would cancel x plus 2 is another x plus 2. Below, I have an x minus 5. And the only thing that would cancel with an x minus 5 is another x minus 5. And this is my answer. A restriction is a value that can't be plugged into a variable because it would create division by 0. When you work with these questions, you do have to be aware that your variable can't be some values because you can't divide by 0. Looking at this question we just worked on when we factored it, notice below that if I plugged in negative 4, I would be dividing by 0 because 0 times anything is 0, and whatever's up top, I'd be dividing by 0, and that's not possible. You would say then that x cannot be negative 4. That is a restriction. Also, right here, you can see that x cannot be 5 because 5 minus 5 is 0. 0 times whatever x plus 4 is 0, and again, I'd be dividing by 0. These are the restrictions. On some questions that we do, I will ask for the restrictions, which would be both of these numbers. But it's very important that you realize that you need to know that x can't be negative 4 if you cancel it out. Because if you cancel it out and it's gone, someone might try to use that equation and plug in negative 4, and it will not work. It's not valid when x is negative 4. I will show you in class that mathematics falls apart if you divide by 0. In this example, we'll do the question and we'll also name the restrictions. Some questions will ask you for the restrictions, others will not. This is divide and simplify. We want a factor. In the numerator, we have x squared minus 9. That is a difference of squares. It is, in fact, x plus 3 times x minus 3. In the denominator, we know that x times x is x squared, that this number times this number makes positive 8. So it's either 2 positives or 2 negatives. The middle there is a negative, so it's 2 negatives. I need factors of 8 that add to 6, and those are 4 and 2. Now notice that we are dividing, and when you divide, you multiply by the reciprocal. You need to take that next fraction and flip it. Up top is an x minus 4, below will be an x plus 3. At this point, because I have multiplication, you must have multiplication to cancel. I can cancel. X plus 3 divided by x plus 3 is 1. They're gone. At the same time, I must remember x cannot be negative 3, because if I plug in negative 3 right there, that would create 0, and I'd be dividing by 0. That'd be bad. I can also cancel the x minus 4's, but I've got to note that x cannot be 4, because if I plug in 4 right here, 4 minus 4 is 0. Again, I'd be dividing by 0. I have one more restriction. X cannot be 2, because here, 2 minus 2 would create 0. My answer then is x minus 3 over x minus 2. And my restrictions, and in WAMAP, it will ask you just to list them separated by a comma. My restrictions are negative 3, 4, and 2. Question 1. These are questions from your assignment. There's a trick here that I have not shown in the teaching. You're going to want to watch this. The trick is to realize that 6 minus x and x minus 6 are opposites. In fact, if you take 6 minus x and you pull out a negative, let's write this down, x minus 6. So I'm going to pull a negative out, and the 6 will become negative, and the minus x will become plus x. At that point, you can realize that this is x minus 6, but negative 6 plus x is also x minus 6. The x is positive, and the 6 is negative. They are, in fact, the same exact thing. They cancel. Now, be aware, when you cancel, they become 1s. So this is actually just negative 1. The same thing happens here because I can pull out a negative, and I would have negative 4 plus 7x and over 7x minus 4. The 7x's are both positive, the 4's are both negative, and those cancel, but that means I'm left with negative 1 again. Question 2, factor, cancel. This first one is 15x over, below I have a GCF of 5, 5 times 5 minus x. What I just did was create my multiplication right here. That's going to allow me to cancel. I'll divide both of these by 5, and 15 becomes 3, and the 5 becomes 1. And then my answer would be 3x over 5 minus x. For the second one, 12x over 24x minus 4. 24 and 4 have a GCF of 4. I'll pull that out. 4 times 6x is 24x, and 4 times 1 is 4. I created my multiplication right here. I can cancel, divide these both by 4. I get 1 and 3. I get 3x over 6x minus 1. For the third one here, the numerator has a GCF of 2. 2 times x is 2x, and 2 times 3 is 6. Below, I have a GCF of 12. 12 times x is 12x, plus 12 times 3 is 36. I have my multiplication. Anything divided by itself is 1. X plus 3 divided by x plus 3 is 1. Remember, the only way to cancel x plus 3 is with x plus 3. 2 and 12 are both divisible by 2. When I divide by 2, I get 1 and 6. Looks like the answer then is 1 over 6. And the last one, the numerator has a GCF of 5. 5 times 5x plus 3. The denominator is just 5x plus 3. And these cancel because anything divided by itself is 1. And my answer is 5. This question did not ask for restrictions. Just to point out that anytime you cancel, you do need to be aware that you can't divide by 0. Right here, for example, x couldn't be negative 3. And here, the restriction is less obvious. To find out what makes that 0, what you would do is set it equal to 0 and solve. Move the 3 over, subtract 3, and divide by 5. And what you would find here then is x could not be negative 3/5. Now you don't have to worry about that here because some questions will ask for restriction, some won't. And this question did not ask for a restriction. Question 3, more factor cancel. This first one's factored for you. Remember that anything divided by itself is 1. X plus 5 would cancel with x plus 5. But be aware, when you cancel, those become 1s. There's a 1 left up top. The 3 and the x plus 4 can't suddenly move to the numerator. They're in the denominator, and they stay there. This is 1 over 3 times x plus 4. Usually we don't remultiply, we just leave it factored because remultiplying actually makes it much more complex in some cases. The second one, we need to factor the denominator. The numerator is x plus 6. Below, that's the quick kind of standard form. Factors of 18 that add to positive 3, but you have a positive and negative, so the easiest way to find them is factors of 18 that subtract to 3, which would be 3 and 6. But when you place them, you have to understand, really, they add to positive 3. That means the 6 is going to have to be positive, and the 3 is going to have to be negative, because 6 plus negative 3 makes positive 3. The x plus 6 cancels. You must have something up top. You're going to have a 1. My answer then is 1 over x minus 3. The next one, the denominator factors. Looks like I have a 7x GCF. 7x times x is 7x squared, plus 7x times 5 is 35x. And I can cancel the 21 and the 7 because they're both divisible by 7. I get 3 and 1. Don't remultiply. Leave it like that. This would be 3 over x times x plus 5. And the next one, the numerator has a GCF of 5. 5 times x minus 2. The denominator is a standard form. The signs will be positive and negative because we have a negative 8. Positive and a negative means we're looking for factors that subtract to 2 of 8 that subtract to 2, which would be 4 and 2. And I've got to really make them add to positive 2, which means you're going to have x plus 4 and x minus 2. Notice that 4 plus negative 2, when you FOIL, will make positive 2. The x minus 2's cancel, and I've got 5 over x plus 4. Be aware again, this question did not ask for restrictions, but here, for example, you know that x could not be negative 4, but more importantly, this was canceled. You know that x could not be negative 5. You wouldn't know that unless you said that, so it becomes important, especially if it's canceled out and it's gone. For the next one, you could say that x couldn't be negative 6 and positive 3. Here, x couldn't be 0 or negative 5. For the last one, x couldn't be negative 4 or 2. At some point, we'll get a question that asks for restrictions. Just be aware of what a restriction is. A value that x cannot be because you'd be dividing by 0. And here we are. We're getting to restrictions. Look at each factor. Ask yourself, what would make 0? Because if you plugged in that number, you would then be dividing by 0, which is not possible. I can see here that x could not be 10, because 10 minus 10 is 0. 0 times whatever x plus 5 is will be 0, and I'd be dividing by 0. Not possible. I also can see that x cannot be negative 5, because here, negative 5 plus 5 is 0, and 0 times x minus 10 would be 0, and again, I'd be dividing by 0. All you need to do here, though, when you list your answers, is write it as a list and use commas to separate the answers. That would be 10 and negative 5. Either order, doesn't matter. Question 6 asks for restrictions. Can you get your restrictions before you cancel? The numerator is a standard form. We're looking for factors of 18 that add to 9. Factors of 18 are 1 and 18, 2 and 9, 3 and 6. So it would be 3 and 6. X plus 3 times x plus 6. The denominator, I know that this number times this number makes negative 24. That means it's going to be a positive times a negative. And because I combine the outer and the inner to make the middle term, one will be positive, one will be negative. When you add a positive and negative number, you subtract them to figure out the answer. You're looking for factors of 24 that subtract to 5. That would be 8 and 3. When I place them, though, really they add to negative 5. Got to make 8 and 3 add to negative 5. That's negative 8 and positive 3. At this point, we can see our restrictions because we can't divide by 0. If I plugged in negative 3, I would create division by 0 because 0 times anything below is 0. Restrictions only come from the denominator. If the numerator is 0, 0 divided by anything is 0. That's not a problem. It's only when you divide by 0. Here, x cannot be 8 because 8 minus 8 is 0. List those with a comma here, 8 and negative 3. At that point, we can cancel. Anything divided by itself is 1. And my answer is x plus 6 divided by x minus 8. Question 9 is another factor cancel. Factor cancel, and don't forget your restrictions. This one asks for the restrictions. 5x plus 20, that's 5 times x plus 4. X squared minus 7x minus 18. I know it's x times x. I know that this number times this number makes negative 18. It's a positive and a negative. Factors of 18 that subtract a 7, since it's a positive and a negative, that would be 2 and 9. But really, they add to negative 7 when you FOIL, the outer and the inner, add to negative 7. That's negative 9 and positive 2. Times, we're not dividing, we don't have to flip the second fraction, just work it out. Factors of 2 that add to 3 are 2 and 1, x plus 2, x plus 1. Factors of 4 that add to 5 are 4 and 1, x plus 4 and x plus 1. We can cancel because anything divided by itself is 1. I got an x plus 2. I'm multiplying. That's what allows me to cancel. I got an x plus 1. I just need something in the numerator and the denominator. Well, look at that. I got an x plus 4. Anything divided by itself is 1. Looks like my answer is 5 over x minus 9. Now, don't forget, before you cancel, you're supposed to list your restrictions. I can see here that x cannot be negative 2, because negative 2 plus 2 is 0. X cannot be here 9, because 9 minus 9 is 0. Right here, x cannot be negative 4, and that one, x cannot be negative 1. List those with a comma, negative 2, 9, negative 4, and negative 1. And this is your answer, 5 over x minus 9. Question 11 is a division problem. There are some multiplication problems as well. The only difference is you don't have to flip the second fraction. When you divide, you multiply by the reciprocal. So this fraction has to be flipped, the second one only. Factor the numerator up top here, x squared minus 6x minus 7 is going to be x times x, a positive times a negative to make negative 7. Factors of 7 that subtract a 6 are 7 and 1. 7 and 1, I've got to make them add to negative 6. That's negative 7 and positive 1. Below, I have an x minus 7. Now, this is going to be times. Below, I'm going to put the x plus 6. I'm multiplying by the reciprocal. Up above, I'm going to factor that x squared plus 9x plus 18. That's x times x, a plus and a plus, and 3 and 6. Now I can cancel as long as there's anything in the numerator and denominator that cancels. They can be diagonal, they can be straight up above one another. They just have to be in the numerator and denominator. These two would cancel, but be aware x cannot be 7 because 7 minus 7 is 0. That is a restriction. And here, x cannot be negative 6. So that's another one. And those cancel. It looks like my answer then is x plus 1 over x plus 3. Now this would be over 1, but I don't have to put anything over 1. Just put x plus 1 times x plus 3. More canceling. You have your multiplication right here. These both divide by 5. You get 1 and 3. These both divide by 7. You get 11 and 2. And I'm looking at 11 and 1 and 3 and 2. There's no common factors in the numerator and denominator. X's will cancel. I'll cancel 4 here and 4 here. There's going to be an x cubed left in the numerator. I'll cancel 2 y's, and y cubed will be y to the first. I don't need to put the 1. My answer then is 11x cubed over, now 2 times 3 will be 6y. The second one, we need to multiply by the reciprocal. We take that second fraction and flip it. This will be times, and I'll put the 35y to the 5th up top, and the 22x to the 4th below. To cancel, I must have multiplication, and then I just need a common factor in the numerator and denominator. And they can be diagonal or right above one another. That does not matter. I could divide by 5, and I get 1 and 7. I could divide by 11, and I get 2 and 3. 3 and 7 and 1 and 2 have no common factors. I can cancel 4 x's and 4 x's. There are 9 in the top. There are going to be 5 left. I can cancel 5 y's and 5 y's. There are 8 below. There are going to be 3 left. My answer then is 3x to the 5th over 2y cubed. This one looks different, but it's not. Factor, cancel. You'll notice that the numerator has a GCF, and you could take that negative out or not. It doesn't matter. I'm going to leave it be. The GCF appears to be 2. I wanted to say 12, but 14 doesn't have a 12 in it. 2x to the 5th. Now I've got that negative. Negative 6x to the 8th. Minus 7. I'm taking 5 x's out. X to the 5th. Plus 6. Just 6. 2x to the 5th times 6 is 12x to the 5th. This is all over 6x to the 10th. The restriction would be x can't be 0 right here, but they don't ask for that. I can cancel the 2 and the 6. That'd be 1 and 3. I can cancel 5 x's and 5 x's, and there are going to be 5 left below. The reason I could cancel is I've created that multiplication. That's what factoring does. And my answer then is negative 6x to the 8th minus 7x to the 5th plus 6 over 3x to the 5th. Question 23 looks different than the others, but it's not. This is really the same thing as x squared minus 5x plus 6 over x squared plus 9x plus 20 divided by x minus 2 over x plus 4. And those two are the same question. What you need to do then is multiply by the reciprocal. Take that second fraction, the bottom fraction here, and flip it and multiply. Let's factor as we write this down. The numerator, factors of 6 that add to 5 are 2 and 3. And I got a positive 6, so it's either 2 positives or 2 negatives. Since we have a negative here, it's 2 negatives. And I said 2 and 3. Notice that negative 2 plus negative 3 is negative 5 in the middle. And negative 2 times negative 3 is positive 6. Denominator, factors of 20 that add to 9 are 4 and 5. And got 2 positives. I'm going to flip that second fraction. The x plus 4 goes up top, and the x minus 2 below. The restrictions would be here, x can't be negative 4, here x can't be negative 5, and here x can't be 2. They don't ask for them though, so we can just cancel. Cancel the x plus 4s, cancel the x minus 2s, and I'm left with x minus 3 over x plus 5.